Okay. Okay. Hi, everyone. This is going to be the web frameworks lesson in Haskell. Before we begin, I'm guessing most of you have some experience with web development, but if not, you could just tell me or through the chat or by voice. It's okay. Because with some concepts, I'm going to assume you know them. But still, I will try to go over it everything fairly slowly and thoroughly. So the idea will be that after this lesson, you should be able to create your own web applications in Haskell, and you should also have a good understanding of the overall ecosystem and which tools you might prefer to use or you might want to try. Okay, let me share my screen. Okay, everyone can see?
Yes.
Amazing. So this is a Haskell web frameworks lesson. The first thing we're going to do is go through like a wide overview of popular Haskell frameworks and web libraries, because of course, to have frameworks, you need a bunch of libraries that you could actually mix and match however you want. So, but we're going to focus mainly on the actual like finished frameworks, because like that's mostly how people start with when you actually in web development in general. After doing your first couple of websites just with JavaScript and HTML and CSS, you usually go straight to like Next.js or React or Vue. And then after you develop some knowledge of how everything should work and you pinpoint the pros and cons, you usually start to like mix and match the tools that you prefer. So that's why we're going to go over just a high-level overview of all the most used tools that are available. And then we are going to talk about the integrated Haskell platform, which is a framework that has pretty much everything ready to go. It's a battery included framework. So you have pretty much no choice on the tooling you need to use, but that's a blessing and a curse, because it's a curse if you have opinions about the tooling that you should be using, but it's a blessing if you don't have an opinion yet and you just want to like build. You want to build, you want to have your product ready to go, so you just go with a pre-built framework and keep going. And after we have this high-level overview and we go over the installations and stuff like that for the integrated Haskell platform, we're going to actually build a web app with the framework. We're going to build a blog app, like we're going to be able to create. We're going to start fairly simple, go over everything, all the code, the files, what each file mean, which one you should care more and which ones you don't edit much. And after that, we're going to start building bit by bit, adding the posts, create post, delete post, CRUD for post, CRUD for comments, and UI and backend work. And at the end, we're going to go over authentication, which is usually something that's a bit painful in every language, unless you use some third-party tool like Firebase. Which in this case is not painful at all as well. So that's really cool. And if we have time, we'll we'll figure out. We'll keep going, adding features or talking about specific toolings. But I think if we made it until auth, you'll have pretty much everything you need to like start building your own thing. Okay. So the first framework that we're going to talk is Yesod. Yesod is a full feature web framework. So it's like a bunch of tools together. We talk about, actually, I think Lars already talked about Hamlet, which is uses template Haskell. But the idea is that it's kind of opinionated, but you still have the flexibility to change tools if you prefer one of the other. So actually, if we go into the link, I'm going to share the slides so then you can investigate yourselves. But this, it's really interesting, and I think Lars already talked about it a bit. So we have these Shakespearean languages that is based on template Haskell. So one use is to generate HTML, but if you look closely here with these symbols, we can interpolate Haskell values in the HTML. And as you can see, we can also like actually expressions, Haskell expressions and actions. But this, at the end of the day, after compiler, this will generate just HTML. Then we have this Lucius CSS, which is, you guessed it, just to generate CSS. But of course, you can interpolate Haskell. This is another version with a small with a small tweak. One is more powerful than the other, but it still generates CSS. And this one, Julius, is to generate actual JavaScript. So you can interpolate, you can write a JavaScript and interpolate a Haskell in it, and at the end, the compiler will generate JavaScript. We're going to go over how the compiler does that, because it's not usually you compile to binaries. So yeah, this will be like a super high level overview of more use cases of template Haskell. We are not going to use this today, but it's always good to know about it. Then we have Yesod uses also persistent, which is the interface between your front end and the backend needs to have some sort of communication. And let's see if we have. So you declare the types here. As you can see, this is inside template Haskell. Let's see if we can scroll a bit. No. And then you can insert in your database blog posts, users, etc., independently on what the actual database is or does. So you can just interact with persistent and then plug and play other databases or other front ends. And so the whole idea is that you write this, and then you have the interaction solved. So in case you need to scale, change the database or whatever, you can just do it right off the bat. So like most or all of the frameworks made with Haskell, the major guiding principle is type safety. The idea of if your application compiles, it works, which is not 100% true, but close enough that you can be reasonably happy once it compiles. because you know that if it doesn't work, it's just a minor tweak away of working. So the documentation, it has haddocks, which is like we already explored, a bunch of haddock documentation, but they also have this Yesod book that you can, the link is broken, but you can just Google. Here we have Yesod for Haskellers and the book. There you go, right here. I believe it's open source. Yes. So, one important thing, Yesod is built on top of the web application interface, which most frameworks are built on top of that. So if you understand what it does and how it works, you pretty much understand the interface, the application interface for pretty much all other frameworks. The previous persistence was to interface your front end with your database, where the web application interface provides the interface to work with the backend. So you can just create this interface and you can use whatever backend or whatever front end you want, as long as both respect the interface. I'm not sure if Lars already showed you this. I think he didn't. So this is widely used throughout the ecosystem. As you can see, it's like the download is crazy. Let's see what we have here. So you define the application type, which if we go here, actually, let's look at the documentation. You have this application type that takes a request and a function that goes to response received and returns the response received. So all you have to do is to define this application, and then you have access to everything that interacts with it, like the middleware response. If we see, I think okay, it's on top. I'm too zoomed in. So we have accessors to the request, and we can actually see them. Once we take a request, we can just like the method, the raw path info, the raw query string, etc. If it's secure or not, to access all the information of the request. And then we can compose, access, and modify responses. So this generates the responses for the front end. Let's see, the response is an opaque type, so we can only I think, yeah, also the request is also an opaque type, so the only way to interact with them is through the functions defined here, like response file builder. We can use streams as well. It's not just like a single communication and closed channel. We can use streams, etc. As you can see, it's really short, and that's on purpose because this is just the bare bones, the bare bones implementation that you will need. But then on top of this, I'm not sure if it shows here. No, but maybe I have it here. So on top of, we can search for why. Yeah, and on top of the why, we have the why extra that provides handlers and middleware. We have the logger, we have cores. So we have all this extra functionality that we can add on top of it. So this interface is actually pretty shallow, but it's the essential, and it works every time. One of the prime users, prime backends that we use in Haskell is Warp. Or Lars already told you about this, that Warp was the fastest backend of Haskell. I'm not sure if at some point or now it's the fastest overall. But this moves really fast, so I'm not sure if it's still the fastest, but at least in Haskell, if you want to use a backend, Warp is the best Haskell can offer. And this is an actual backend. So the Warp will interact with Y, and you will have everything, all the interactions already predefined, and then you can just interact with the you can just build the request and parse the responses based on Y, and have this super fast server running independently of whatever you do on the front end. Let's see. Yes, as you can see, we have this network Y handler, so like to have this interaction with for Y, and we can run the server. We can run with an environment, with settings, with sockets. Of course, we can create settings, the ports, not so interesting, this part. We can get information, the ports, there you go, exceptions, handlers. This is really, really useful. If anything goes wrong, you can like prepare for any eventuality. Here are the data types. The port is just an int. In the case of an invalid request, we have all these constructors that we can pattern match, and for every construction we can make a different a different response, a different handling. And for utilities, well, I'm going a bit fast, just let me know. But this is just an overview of the tooling we have available. Then we're going to actually use them. But I want to give like the whole overview in case we don't have time to cover everything practically. And I want to make sure that you have the whole picture. So for utilities, not much. So as you can see, like the cool part is right here. So you can just run the server. And let's see, I think we're going to use this later. So let's keep going. So YESO takes all these, it takes Hamlet, persistent, Warp, Y, and puts it together to have this predefined framework that you can just straight up use out of the gate. The thing is that you have to know a bit about how everything works, just a bit. It's not, this framework is not terribly hard to learn. Let's see, I think we have a mess.
Yeah, we have a question, Robertina?
Yes, what does Warp map in the imperative world, i.e. Apache? Okay, so Warp is the actual server that is running. So maybe it will be more equivalent to like Node.js or Ban in the imperative world that is more used, is more widely used. So it actually takes requests, process them, and generates a response. That's it. That's like bare bones, what only Warp. So it's just a bare bone servers, has no backend, no database, but it has this interface that you can interact with, same as with Node.js. Node.js has Ajax. I'm not sure if right off the box, but it has fetch, and it has it can generate response as well. So it will be like pretty much the same functionality. And there you go. Okay, so then we have this list of sites that I'm not sure. Yeah, so high traffic sites that you can just poke around, and not sure if all of them are, no, likely not all of open source, but some of there are. Like here we have a GitHub here as well. So yes, sites, actual like full-on applications, high traffic sites, which this like Warp and Haskell in general has great support for high traffic. So that's a huge win in the case, thanks to like all the purity and this speed it provides. It makes it super easy to work with concurrency and parallelism. And some personal websites. So this, I'm going to share the slides so then you can like take a look at them. Let's close all this. So this will be, Yesod is not terribly hard. So if you're curious after this lesson, we're going to go over a few of the tools, but in a different framework. If you're curious, you can take a look. Miso is a bit different. This framework tries to go to double down on isomorphism, and like the word might mean like it means multiple stuff right now. So we already talked about isomorphism before, but in this case, in the case of web frameworks, front end, back end, isomorphic means that you can write code that can run both in the front end and in the back end. The whole point is that, for example, if you're saying, okay, but I can already do that with like React and Node.js, for example. I can write code and it's both JavaScript. Yeah, but no. The thing is, Node uses specific functions that are only available in the server. And in the front end, if you use React, you have a specific functionality that's only provided by the React library that is not available on the server. So if you only use vanilla JavaScript and not like a specific functionality that can be present only in one or the other, in that case, yes, all that code you could move that code to the front end or to the back end to generate optimizations or whatever, and that will be isomorphic. This is a trend I think started or encouraged by the technical team at Airbnb. So the whole idea is that we're not sure if it's better if X process, like this specific process, is better to do it in the front end or the back end. So we're going to write a code that makes it easy to move it or optimize it, and use it both in the or one or the other in the front and the back end. So in the future, when we have more data, we can move around. So that's the whole point in this specific context, what isomorphic means. So this is pretty interesting. Yeah, we're going to get to that. So of course, the features, let's search for Miso so you can like take a quick look. Here. So front-end framework, let's see, has, yeah. I have the website here. This is a website, fast, because as a virtual DOM diffing algorithm, this is kind of like React. when you update the DOM in React, it doesn't update the actual DOM. It has a virtual DOM that it's updated, that compare is defeat with the actual DOM, and only the parts that change are updated. This is pretty much the same. Isomorphic, type safe, of course, like that's the whole point of using Haskell. And concurrent, interoperable, because it uses GHC.js for foreign function interface. So we're going to talk about that in a bit. Here's the repo. We have a bunch of examples. Let's see. Something that might be a bit not too worried, not too. So I think this one has, yes, okay. Here's the representation of the data type, and as you can see, we can like play around with this quite a lot. So it's interactive, like the whole. If we're going to discuss this actually right now, why not? So the whole point of being isomorphic is that you want to run both in the front end and the back end, but the front end only runs JavaScript. So how do you do that? So the Haskell compiler up until recently could not compile to JavaScript. So we have this GHC.js compiler that is actually at some point was a fork from GXC that's specialized in JavaScript. Now, like after so much time, it's already a huge, like its own thing. But the whole point is that using GXC.js, you could write regular Haskell, nothing weird. You don't need special tooling or everything, just the actual compiler. And you can compile that to JavaScript. So thanks to that, we can, for example, write only Haskell that can work both in the front end, in the back end, and you have even a choice. You could even say, okay, I want to compile, I want to use Node.js or some V8 interpreter, V8 engine in the back end, and I will compile Haskell to JavaScript. Or you could have the Haskell compiled to binary for the backend and JavaScript for the front end, the same Haskell. This was highly successful project. It is a highly successful project, but thankfully, it's already actually, so I think the last version of GXC already has this backend integrated. So you don't longer need to use a separate compiler. You can just use GHC with a special flag that lets GHC know that you want JavaScript, and that's it. Now you can, with the same compiler, with the same GHC, you can compile both for binary JavaScript and potentially as well WASM and potentially other stuff. But for now, I mean, I think pretty much everything we need is binary and JavaScript. These are like two main, and of course WASM as well. We have a backend for WASM as well, but it's not that's used. It's kind of new, and I think because JavaScript has this wide adoption, it's of course a priority to support JavaScript. So this compiler has been merged with the original because this project always was a bit behind the actual GHC compiler, of course, because like the actual GHC compiler has like more people working on it, and it keeps going, keeps growing, keeps improving, and this the GHC.js compiler needed to like try to catch up. And sometimes the trying to catch up will be like too much of a gap, and a big difference in features might arise, etc. And so, but it's been so useful and being like so widely used as well for the Haskell community, because you don't want to write actual vanilla JavaScript, but you want to run your apps on a browser. So this was like a great solution. It was merged. Still, all the frameworks we're talking right now are still, not all of them, but the ones that compile to JavaScript still use GLC.js, because the merge was really recent, like really the last version of GLC, I think. And the GLC.js has a bunch of optimizations that were implemented throughout the years. So it's still faster. The final product, the final JavaScript is still faster using GLC.js. Luckily, so all the frameworks that still use GLC.js for now, but the developer of GLC.js is working with the GLC team to made a complete integration and eventually add all these improvements. So looking forward to that. Maybe it won't be long until we don't need to maintain a separate compiler. But the important thing is that we now for years now, we could compile not only to binary but also to JavaScript. So that opens a lot of doors for Haskell. So in the backend, Miso uses this server style routing, and of course has this type safe, because I think we already went through servant with Lars. Let's see, just one quick example of how it looks, structuring APIs. So this is the whole point. Why? Okay, I don't know if I can close this, but yeah, this is an API. For example, you defined an API at the type level. We didn't cover type level programming in this course. It's a bit more advanced, but actually now not so much. If you went through everything, if you did all the homework and you understood the lesson, actually this is just a small step. It's a lot. Is type level programming is like a whole field, but if you want just to use the tools, it's pretty simple. So you can pick it up pretty fast. So the whole point of having the actual API, that this will mean we'll have the URL, factoring the URL, and then this will be like a / users, and we have to provide, we're going to get a user ID, and this is going, and the other option is to have the API. If you remember, this looks a lot like the alternative symbol, but with this column, because we are defining our own at the type level. This is not at the value level. So we can have this API / users, and we're going to get the users ID, or / products, and we're going to get the products ID. The whole point of this is that if you misspell products, for example, this is a type level string. That means that the type is wrong and the compiler will catch the error. So there's no way you can actually compile your server if you misspell anything, for example. So this is inspired by Redux. I'm guessing most of you, if you already work with some capacity, mobile or web applications, Redux, state management. Elm is a domain-specific language for building front ends in a language that looks quite a lot like Haskell, but it's actually a bit less powerful on purpose because you don't need the whole power of Haskell for working with Elm. Jason, yes, that's a question. Could you expand more on factoring API for servant? Yes, I think I am not sure if we should right now because we didn't cover type level programming. But maybe we could make an example. Yeah, I think we're going to, yes, of course, Jason. Maybe we're going to leave it till the end just to make sure that I get to cover everything I want to cover because it's quite a lot. But yes, servant is really useful, but it uses a certain level of type level programming that we didn't cover. We're going to see a bit of type level programming today because we need it for the framework. But yeah, I think it will take more than the time we have available here right now to go over like how actually like the whole servant works.
Yes, it's a complete lesson, I think.
Yeah. But yeah, good question. And if we have time, we might cover like super quickly, or maybe we could actually add, we can discuss this with Lars, but if we manage to cut a bit of time, like make other lessons a bit faster, we can like maybe plug a quick lesson on type level programming. I will try. I will ask. Okay, so this is really cool. And oh yes, Elm. I forgot about Elm. So this is also a really interesting language that you might be inclined to use. It looks like Haskell. Let's see if the playground provides some buttons. There you go. A bit too much, or can I? Yes. So Elm looks a lot like Haskell. Actually, the Elm compiler is written in Haskell, but the whole point is that it's specialized to work with front end in JavaScript, front end that compiles to JavaScript. So you could actually write code that feels like Haskell with less powerful types and less functionality, but more than enough that what we need. For example, this code, we have the main function with 3 functions, the init, update, and view. This is based on the model view. We'll have a slide about that. I think maybe we can just skip ahead just quickly. Yes. Elm says same as the IHP framework, uses the model view controller structure. So you have this model that is the central components. This, in our case, is represented by a type that represents the state of the model. And this type doesn't care how it's managed, it doesn't change, and it doesn't care how it's shown. It's just raw information. Then we have the view that is a representation of the model. If you have a bunch of information, you could represent the same information in a chart or in an like something like a table, like an Excel file, etc., or a text. But the information is always the same. So the whole point is to separate the actual model, the information, from how do you represent it, and from how you change it, because of course information change, and we have to manipulate the model, and for that we have controllers. These controllers are the ones that interact with the user interacts with. So a button, for example, a user clicks a button, so the button uses a controller to modify the model gets modified, and then we update the view with the new model, and the user sees that view and interacts again. So that's this is a quite standard way of doing interactive programming UIs in general, not only for web, but also for like applications and GUIs in general, and graphical user interfaces in general. So I'm guessing most of you should know about this already. If not, just in case, I'd put it there, because the framework we're going to use is highly influenced by, it's like actually is strictly uses this model. So Elm uses the same model, so, the same architecture. So we have this model, and the model, as you can see, the type model is just an int, and it's an int of value 0. And then we have the controller that we use to update or modify the state. The controller can be either is of type message, and it can be either increment or decrement. And here we have the actual update function that modifies the actual controller, that takes a message and a model and returns the new model. As you can see, this looks a lot like Haskell. So we have the message in the model. In the case the message is increment, we update the model, we change the model, add 1 to it. Remember, the model is just a type synonym for int. And if decrement, we subtract 1. That's it. That's the model. That's how we modify it. And then we can choose however we want to view it. In this case, we have to define the view, and this the view function that takes a model and renders an HTML. And in this case, we create a div that has no attributes, but it has a button that with the action on click decrement and the text minus, this button right here. Another div with a text. This text is, as you can see, we have the model, and we extract we convert the model that is an integer to a string, and we pass it to the text HTML type. So this is right here. And finally, the same button, but in this case, when on click, we have the increment action and a plus. So it works as expected. It's a pretty simple architecture. We're going to see more complex examples when we're going to actually do it in Haskell. But I think this is actually a really nice really nice front end. It's highly interactive, and in our case, we're going to use something that's geared to more to the back end. So everything is safer and processes super fast in the back end, but it might not be as interactive in the front end. So the framework actually provides a way to combine this same language for the front end with the already provided tooling. So let's see. I think I went too far. So as I was saying, Miso is based on this architecture. Actually, we could take a quick look at how Miso looks like. Let's see. I think there was an example. Let's go to quick start. Examples. No, sample application. Yeah, here. Let's see. This is just an overall idea, so you can take a look if you want. So as you can see, we have the model that is an integer. We have all the actions that we can do, that we can apply to the model. We can add one, we can subtract, no op, no operation, and another one says hello world. So when we start our main entry point, uses the start app application that takes on the application. And where we have all these parameters that we need to choose. So in this, we have the initial action that needs to be executed when the first time the application loads. We have the initial value of the model. This, in this case, is just hard-coded, but you could retrieve this from a database. We have the update function that we're going to define later. We have the view function that we define later, the default events, it's the events that we can use. The subscription list is empty. We are not, our modules, our website doesn't depend of any stream of information, incoming stream of information for now. The mount point is just, if you put nothing, just go straight to the body div, like same as React. And how do you want to do the logs? So as you can see, we already have this model and the type model and the type actions here. So we are needing the actual way to update the model and the actual way to view the model. Update model, this is Haskell, but it looks a lot like Elm. So takes the action, and for every action you can just add choose whatever you want to do, and then this just updates your model that can be later or at the same time linked with the database. And the view model is pretty much the same as Elm, but in this case we have these underscores here because it uses one of the languages that I told you about previously. This is, I think, Blazed HTML, or I think so. Let's see. HTML. Let's see. I want an example. Here. Okay. Okay, here, this is Blaze HTML. So it doesn't have the underscores, so it's a different one. I don't recall exactly which one it uses, but I'm sure somewhere in Miso's website says. But the whole point, as you can see, we have a lot of languages that compile to several other languages, HTML specifically, because it's way easier to template. It's like a important and highly requested feature to template to HTML because the web runs like pretty much everything. But yeah, this is a button on add one, same as before, so I'm not going to bore you with this. And that's a bit like a super short overview. It uses Nix. I think all of the frameworks I'm going to talk about today use Nix. Nix it's used quite a lot in the Haskell world. I think I'm going to talk about it later, though, not right now, because it's a lot. But we have to go over it when we start working on our website, because it uses Nix and it plays an important role. But now our final framework before the one we're going to actually work with is one of my favorites. It's also a batteries include framework, but in this case, you can create a single source code that compiles to web application and Android and iOS. So you can create a single app that compiles to everything, kind of like Flutter, but Flutter is more geared to mobile. It started with mobile. Obelisk, I believe, it started with web and then expanded to mobile. But it's really cool that you can have this. You can write on your favorite programming languages with type safety and pure functions and whatever you want to. Any of the thousands of tools you have available, libraries that you have in Haskell, and you can then compile them to web, mobile, and everything at the same time. So that's I think it's really cool. There's a price to pay though. The price is that it uses Reflex. Reflex is a concrete implementation of the concept of functional reactive programming paradigm right here. Functional reactive programming is one of the proposed solutions by the Haskell community and other communities that work heavily on function style programming to the problem of matching the event-driven nature of a graphical user interface to the functional paradigm. So in general, if you think of a graphical user interface, it feels natural to say, I have this current state and the user is going to interact with my front end, and I'm going to modify several times this state and update the UI in terms of that modified state. So that requires mutability, and that requires side effects, and it's not intrinsically, but it's the first thing that comes to mind is to use this big state or a couple of widely accessible states that you can modify. And that goes against the functional paradigm, like fundamentally. Functional paradigm doesn't want to keep a global state. It just wants to take a function, take a value, and return another value, and that's it. Though I don't want to keep track of the state, which in that case, if we want to keep our purity, we want to keep the paradigm of functional programming, we have to find a way of adapting or adapting the framework that we use to the event-driven nature of GUI, because like graphical user interface is not something with constant change. It's not something static. It's something that is there, and at some point that I don't know, because I have no way of controlling what the user is going to do, events are going to be fired. The user is going to type, the user is going to click, the user is going to drag, and those events that are going to be fired need to be processed in some way or another. So functional reactive programming is just one of the solutions, but I think is a really nice one. I personally like it a lot. And the Reflex, this is like the functional reactive programming is like the idea of doing something a specific way that we're going to see in the next slide. And Reflex is the actual implementation, like an actual library that runs and compiles and works that uses this idea. So the goal of Obelisk Obelisk is made and used by a company called Obsidian Systems that builds applications and web and mobile applications has been building for years, and they open source their framework. So they build in production. So whatever they do, it has to actually work in production concurrently with thousands of users. So it's battle tested for us, and it's free, so we can just use it. Obelisk also has this uses GSC.js, so it compiles to JavaScript and has a full tool set, ready to go, tightly coupled tool set to use GSC with Reflex and Haskell, etc. And of course, the primary user of this framework is Haskell developers. And their claim is that if you want to build high quality web and mobile applications in Haskell, without having to build your own framework, that you should use Obelisk. That's at least their claim. The thing is that if you have to use Reflex forcibly, that means that you have to learn functional reactive programming. That is both that can be thought both as a downside, because I have to learn another thing and it's going to take a while and I just want to code. But that might be a downside. I mean, if you already are familiar with Haskell like you are right now, it won't be a huge ask to learn functional reactive programming. You could do that in a weekend, or maybe 4 days of actually going through building a small application. But it's 4 days that you are not starting with your own project, right? So that might be a downside, or an upside, because you're going to learn a new way of thinking about a graphical user interface, because the paradigm is quite different. We're going to have a super let's before going to the overview, let's search Obelisk. There you go. There you go. So this is a repository, Obsidian Systems /Obelisk. And as you can see, we have a bunch of resources for developing the Obelisk project and project using Obelisk, deploying and compiler to iOS and Android. And I think it's quite easy to get started. You need Nix as well. We're going to talk about Nix later, but as you can see, another tool that uses Nix, and you have just a bit of configuration. Add this to a couple of configuration files, and then you run this single command, and after waiting a bit for the binaries to install, you have Obelisk. That's it. Then they have this OB tool that gives you the most common actions that you need to run. OB init, that is kind of like npm init, or sort of like a create React app for Obelisk. You have run to start running the backend and the tooling. Same as we use Google online. In this case, when you have these specific tool sets that you use, it's nice to have Google but not like in general, that if you use maybe not so famous library, you don't have access to like Google didn't add to their database because it's too small, few people use it, or because it's too new and it doesn't have the time. So plenty of projects, not just Obelisk, but plenty of other projects. Plutus, for example, the language that we use as well does this, has its own Google that you can launch in your local host and search for the tooling that you are actually using, like the libraries of the exact versions and the exact libraries that you are using for the project. So that's also really nice. And then this is an X expression, but yeah, you can add your own packages, etc., etc. I'm not going to go over everything, but if you want to get started, you can start with installing an Obelisk and go over, like, read through, as we have IDE support as well. This version is quite old. Currently uses for by default. Okay, 8.6, but you can change it. Okay, amazing. So we are now in 9.6, I think, 9.6.10. If you want to get started, it's pretty easy. You need niche. You need Nix. Like, that's not an option. There's no Docker available for you to use. And that's on purpose. They want everything to be reproducible. They don't want to risk you having something different that it shouldn't be there, or badly configured. But I think we're going to stop there for Obelisk. It's really interesting. We're going to go over the underlying concept behind Obelisk, which I find it quite nice. So we talk about a functional reactive programming. The Obelisk uses that, but what is? So the whole point of functional reactive programming is to avoid having side effects by adding time as an input of every function. So this is the thing. There's like the in the slide says, all potential impure functions have a time parameter now. And the functional reactive programming system makes sure that every call to such function is done with a new and unique value. So what does this mean? Like, when we run get character in our interactive environment, is of type input output char, IO char, because we are performing the side effect of opening, of getting an input from the user, and then, like, displaying or save it somewhere. So it's a side effect. It's something that's the bad thing about side effects, like something that goes against the well-being of the developer, is that if you run the same function twice, you have different results. If I run get char twice and the user puts different values, I will get different values. So there's no transparency, there's no referential transparency, and I cannot move around the function however I want, because I don't get, like, I don't get I have no idea how that's going to change the result. So the solution in Haskell is to add this tag that says, okay, watch out, get char is actually has side effects. So the actual representation of get char is still referentially transparent, but as soon as you run it, you have an impure action, and you have to make sure to do it in the sequence you want. So functional reactive programming avoids this by adding the time parameter, and the time is the actual real time. So there's no way of running the function twice with the same time, because the time already passed. We cannot go back to the past. So getChar in functional reactive programming get a character for time like 1, like time 1, the beginning of the universe. You run getChar and you get like an S, because the user input S. God, because I mean, just get it started. So if you run getChar again in second 1, you should get S as well. But because that's impossible, because time keeps moving forward, there's no way of getting the same value. There's no way of getting of providing the same input for getChar. So you are free to return different outputs for different times. That's how functional reactive programming solves this issue of having pure functions that at the same time interact with external users. Because the input changes, the output is allowed to change. So we can remove this IO, this side effect, and just add time as an input. So that's pretty much it. That's how elegantly it's solved. And in practice, we have 3, which called time-dependent data types that are pretty much that represent pretty much anything anyone could do interacting with the values. So the first one is the event. An event is a click or a type or a letter typed in the keyboard. Events occur at some points in time, and they have a value. Like the click is maybe true, and the key might be a K or a Q, so it's actually value. But an event doesn't need to have a value. If in a specific second, no one did anything, the user is just reading the website, is not doing anything, in that second, the event has no value. In the FRP framework keeps checking every second, and at some point the user interacts, and in that second is going to be the event is going to fire, and we're going to have a value, and then we can react to that value. On the other hand, we have the behavior, not the opposite, but something that like covers the other face of the coin. The behavior contains a value. It always has a value, and this value is allowed to change over time. As always, every tick of a second, the value it could change or not, or could stay the same. But it's not possible to notify when a behavior changes. For example, when you have the stock market or whatever, you have a stream of values that get in, and you and the actual like price of ADA goes up, goes down, whatever. If you represent it with a behavior, this value is going to change. You can read it, but it's not possible to be notified about this change. But we usually want to get notified. We usually want to, for example, trigger an event based on a value. Like we can put a threshold. If the value of ADA goes up at some point, I buy more or whatever. I want to trigger this effect. So in that case, there's this dynamic that is actually dynamic is not for every, it's not implemented in every functional reactive programming implementation, but specifically in Reflex, but Reflex is the most widely used. So dynamic is same as behavior. It's just a container for a value that can change over time, but it allows notifications of changes. So you have this notion of at some point, the value change in some way that I can trigger an event. So it's kind of like merging the functionality of event and behavior. I find that's quite interesting. And on top of that, you can build a whole system that respects referential transparency and purity and still interacts greatly with the end user. So I think, yes. The last one is the IHP framework. That is the one we're going to actually use in the, let's see. Okay, yeah, so we're going to have this overview. And then sorry, I'm a bit late with the break, but just 10 more minutes and we can have a break, and then we can start working on the actual website. So there's somewhere, not right here, but maybe here. There's examples for Reflex, workshops, guides, workshops, presentations. This is quite interesting. I really like it. Okay, but let's close all this. And let's open okay, so the integrated Haskell platform framework is the one where we're going to actually use to create the website. Let's go over first the features and then why I choose this one to work with. First is a full stack web framework. So you have not only backend, but you have also front-end, backend, and you have a database already integrated, ready to go. So it's pretty much the whole package to start working on whatever app you need. Then we have this a fully managed development environment that uses Nix. Fully managed means that if it works in one machine, it should work in all other machines of the same architecture. So if you have an Intel chip with Nix installed and you run the development, this development is going to be it's going to be created, it's going to be reproduced exactly as any other Intel machine. That means that if you did something while working that works and you push the changes, it will work on all other co-workers' machine. So like the problem of it works in my machine is solved pretty much, unless one has like a MacBook and the other one has an Intel chip, a MacBook with an M1 or M2 chip, and the other person has an Intel chip and an x68-bit chip. So in that case, you might need to configure some extra things, but for most people, and I mean, it still works if you configure for, there's most tools still work on both machines. It's just that it might take like one more year for the whole ecosystem to catch up with the new architecture. But that's a huge improvement. You don't need to learn how to install all the tooling. You don't need to make sure you have a specific version of anything installed. It just works right out the box. And we're going to actually do that. One thing that is provided by this framework is this the library loading in development mode, which if you used Next.js, is the same. Every time you save the file, you the framework runs the changed files and updates the state of the web application. Of course, robust type-safe applications, if you do things the right way in development, no, you will be, if you are able to compile, you have pretty much no runtime error in production. And one thing that we're going to explore as well is that you can refactor with confidence. Lars said it, I think, a couple of times, that Haskell gives you this superpower, not more than superpower, confidence. It gives you this confidence that you can just break stuff and the compiler is going to let you know where everything broke and what you need to do to fix it. So we're going to do that as well. That's going to be really fun. And faster production environments. So that's something specific for this framework. The response times around 30 milliseconds, which is super fast. And has this instant click thing that Next.js has as well, that when you hover a button or a link, the framework is already fetching whatever you're going to click. So by the time you are clicking, it's already loaded or pretty much loaded. So it feels instant. For the perception of the human, feels like it was already ready to go and loaded in your local machine. That's pretty cool. And we have this integrated development tooling that is really cool. We're going to see that as well. It's like a no-code, low-code tool with an UI interface. And finally, this, I didn't test this myself, but the Digital Indus company, the people that created this, the company that also uses this in production and created this framework, have been using this since 2017, and they claim that it scales perfectly well. And I'm inclined to believe it, because I have no reason why. I mean, they use the super fast server, and the concurrency is implemented as it should. So I do believe that it should work. It should scale pretty fast and pretty good without any major issues. Okay, before going through the actual installation process and going through the tooling of the integrated Haskell platform, let's take a break. Yep. What do you think? 10 minutes, 15 minutes? Because I ran a bit too much. Okay, 15 minutes.
Yeah.
Okay, okay. See you, everyone. So far we did this high-level overview of some of the most widely used web frameworks. Not enough to get you started with any of them, but good enough so you can then like know what to look for in web frameworks and where to search for. If you want to know about more web frameworks, I think Haskell, you can search for Haskell web frameworks, and the official Haskell wiki has like a huge list with more web frameworks. But I think it's fair to say that it will be better to work at least with this framework, just make one thing with this framework, and more try one of the others that I spoke about, because they are more up to date, more well maintained. They have maybe a couple of them, including this one, have a company behind them, so that makes them that there are people getting paid to keep them up to date. It's not like a pet. No, they are not pet projects. But now let's start with the fun part. So let's talk about the integrated Haskell platform. So it's the library dependencies are on the operating system side, uses Linux, but it's not actually required to have Linux installed in your machine. And I have Mac OS and it runs perfectly well. But what you need is a Unix-like system. So you have to be able to run Nix. In that case, if you use Windows, you can use Windows Linux subsystem for Linux, and then install Nix there. There you go. So Unix and Nix are dependencies for this platform. Postgres SQL is the chosen database for it. There's no alternative. Basically, if you want to use right now, at least, if you want to use this framework, you have to just use this. The whole point of this framework is that someone else make the decisions for you, so you don't have to do anything about you have no way to change, or at least it's super hard to change things from the backend. But what you get in terms of that is that you don't need to like research and do all the stuff to like see which tools you want to use. If you already know, Postgres SQL is the most widely open source SQL library, open source. So it's like a reasonable choice. And what you get as well is all the helper functions that it's already pre-written for you to interact and interface with this library. So you can just start the project and get going, and like if you need to query, if you need to construct a query to get something from the database, if you need to write, create, update, whatever, everything is already like ready for you, so you don't have to reinvent the wheel. He also chose as default the Bootstrap CSS library. That's not mandatory. As you can see here below in the optional category, we can use Tailwind CSS or we can just use plain CSS. So that's the front end side is flexible. It's really flexible because what the platform cares about is the backend side. Actually, like most of what we're going to work with is backend. It's like 99% backend stuff, because the HTML is rendered in the backend and then sent to the front end. And we can sprinkle by default, we can sprinkle now and then some JavaScript, and we can actually, like, if we want, we can create our own JavaScript files and import them and use them inside. But by default is pretty much heavily geared to backend templating. The cool thing is that we have the choice to change the front end. We're going to work, the front end uses HSX, which is like JSX in React. Because you get to write HTML, and with curly braces, you get to inject JavaScript, like actually write JavaScript inside the HTML. This is pretty much the same, but for Haskell. So actually you can HSX HP package. So there you go. As you can see, we have this view of type HTML. It uses this untyped template Haskell, like as we saw with Lars the other day. And here we have looks like plain HTML, but actually under the hood is this library called Blaze HTML that we Blaze HTML that we already saw a bit about it. Attributes. For example, here if you write, for example, div exclamation accept bar hello, it's this accept is the attribute accept of value bar, and this is applied to the hello, so the hello string is wrapped inside the div. So this, of course, is less usual. You might like it. Actually, if we have a bigger example here, you might like using this syntax. I particularly don't. I prefer. I find I work for so many years with HTML that's it's pretty intuitive for me. So I prefer just to write HTML than to write functions that take something, that take another thing. I love this for the actual logic, but for templating, it feels more natural just to write HTML, because as soon as you, with a quick glance, you know what's going on. So that's the whole point of using template Haskell. You have this HSX library that allows you to write something like looks and feels like HTML, but then it's compiled to this in the first pass. And that's really cool because we get to have a type check in HTML, which is really convenient. So there's no way to write a wrong closing brackets, and that allow that to run. That at compile time, the compiler will let you know that this doesn't type check because you are doing like the wrong thing. So you get static typing for free, because you're, instead of having to write this, you just write what it looks like to you, regular HTML. So the backend, same as for the for Yesod and for many or most other frameworks, the web application interface with the actual backend with Warp. As a database, because we're using Postgres SQL, the database we use is a Haskell library called Postgres SQL Simple, with some companion libraries package. Let's see. Postgres, my bad. Postgres. There you go. I'm super zoomed in. So it allows us to, in Haskell, create queries, extract results, use types, manage our connection with the database. I think that's pretty much transaction handling, but that, I mean, creating queries and getting the result, manage the transaction, that's pretty much everything you need to know to do. So the simple SQL library has this query type that is a new type wrapper around byte strings. So it's just byte strings. Let's see if we can see the source code. There you go. That's the query. Just a record type with a single field called from query and a byte string. So the reason that we wrap the query in not just use byte string is for type safety, of course. So the query string, you could, if you have overloaded string, Lars used that a couple of times already, you can just write your query is as a text, like select everything from this table, whatever. But you can also construct the queries using these helper functions. Let's see. For example, here we have this from row class that we have this type. This type in Haskell corresponds to a type in the database, to a table in the database. So we have the table user that has the column name of type string and the column file quota with type int. So you create this instance if you want to use PostgreSQL simple, you have to create this by hand, but the framework is going to create this for us, luckily. So you have to create this instance from row to get information from the row user where user has these two fields. And let's see if it uses at some point this. No. Well, we have the from, then we have other ways to like write and read, etc. Here's when we create a raw query. This is like when you want to create something that is not easily created with the helper functions, you can just write the query straight off the bat and that's it. But usually for most cases, when you want to run a row, read rows, select everything with every user with age over 18, whatever, you can just use these the helper functions. Let's see. We have something nice to show here. Well, so this is one of we're going to use this library, so no need to go over this right now. The connection as well, you can manage the connection, but our framework is going to manage that for us, luckily. So the connection is already taken care of most of the time. If we can choose to, depending if we are running locally or if we are running in production, we can connect to a different database, etc. So all things that everyone should expect. So we're going to interact heavily with the PostgreSQL simple library. The backend is going to just run for us. It's going to be generated. The code is going to be generated for us automatically. So we're not going to interact much with it. We are going to use HSX quite a bunch. And we have, of course, a ton of language extensions activated because it's plenty of these MTL lens, ASON network containers that are like foundational libraries that uses under the hood need these language extensions, and our use case is going to need. We're going to pretty much ignore most of them. We already cover, like throughout the course, Lars cover a good, maybe a third of the ones that are activated here. Others are type level stuff that we don't need to go over to actually use the framework. And a couple of them we're going to take a look when we cross paths with them. So one thing that is really cool here, it says optional, that we can use Elm, PostScript, HTML, NPM, etc. We can go to their website and go to the docs. And here at the end, we have front end. And then we have a whole thorough instructions of how to integrate Tailwind, how to integrate Elm as a front end, as the front end, PureScript, that is another language that compiles to JavaScript that looks and works even more like Haskell. HTMS and HyperScript, that's really it's a huge. It's been talked a lot during the last few months. Like it's an old technology that now everyone is getting hyped about for some reason. They rediscover the technology and now everyone wants to use it. We can have models as well, like popping models in the front end. This is a separate thing that you have to activate. We can just use NPM and you can do whatever you want, because most languages, most frameworks, you can just install using npm. I mean, you can manually integrate a view or whatever you want, and etc. etc. So let's see. To install IHP, we need Nix, of course. I wanted to talk about Nix, but maybe if we have time at the end, because I don't want to have, like, I want to do as much as possible from the app. But Nix is a really powerful library. It's actually a language, an actual language. It's a lazy functional language like Haskell, but way simpler. It's not dynamically typed, so it no types. But it's really cool in that you can you can declaratively and configure whatever you need, and actually like scripts, installations, and CI, CD pipelines, your own operating system. I have my whole operating system is configured with Nix. So every time if like something's wrong with my computer, or if I have to change it, I just have to run the Nix expression and everything's going to be installed and configured same. Or if I want to deploy, which is more common, if I want to deploy a server with a specific configuration and I already have it, I can just deploy the server with the Nix expression, and I have the same exact server, which is really important if, for example, you want to scale your application. You have an app that has a server that cannot scale vertically anymore. Like you topped your RAM, you topped your hard drive, you topped everything. So there's no other option that scale horizontally. If you have your server declare with an Nix expression, it's just a matter of 5 minutes to launch a new server that has the exact same configuration without you having to tweak, and you can have the confidence that it will work the same as the other server. So that's in production, that's really important. Especially if you need to scale, that means you have a ton of users that you have to solve right now. So if we have time, we might go over a bit of Nix, because I think even if you don't use Haskell framework, even if you don't use Haskell, knowing Nix is a huge upside. I'm going to use Nix to deploy my own local instance, but you can as well have use Docker, and it's already prepared for you. You have these VS Code Docker containers. There's GitHub code spaces, so it's online. You can actually try to follow this lesson without installing anything on your local computer. You could use GitHub code spaces or Gitbot. And actually, if we go to I think it's the first one, installing. Let's zoom a bit. So here we have here code spaces or dev containers. To get started on code spaces, simply use the code spaces IHP template. Let's open this. There you go. So we have these code spaces templates. If I click here in Gitbot, I should get the running. Else, if you want to go code spaces, you have to clone a repo with this template and run it in your code spaces or your local dev container, same as with the other. The dev container is the same as with the Haskell container that I created for you. So still, after the lesson, I'm going to add all the source code that I'm going to write today to the main repo. So if you run Nix, you can just do it locally. Else, you can just clone that and run it in code spaces. So it's pretty friendly in that regard. At the end of the day, everything runs on Nix. But if if you don't want to install Nix in your local machine, you can just use this remote or Docker that has inside install Nix. So, I mean, it's a bit redundant to have Docker and on top of Docker Nix, but it's useful if you don't want to use it. So let's start a new project. I already have installed the framework, which actually is pretty much some catches that you can add to Nix to install everything faster, and this binary, IHP new. So if let's zoom it. IHP new Kenya. Here, this is a Nix thing. It's asking me if I have a cache, because the binaries can be, usually you get the source code and your local machine has to build everything, but you have also the option of using services like caches that is also like pre-configured by the owner of the repo, that allows you to download the pre-built binary, so everything is way faster to build. I don't need this because I already have this. And there you go. It's already, that's it. No, wait. Yep. Okay, so this is super fast for me because let's see. Oh, we have. Yes, thank you, Karina. You have yes, you have the link there if you want to like take a look. So it was super fast for me. Let's see if I have HP. Yes, okay. So it was super fast for me because it's not the first project that I run. So all the binaries and everything it's already in my Nix store. So there's no need to rebuild it for a new project. So this is all, everything is, I know it seems like a lot, but it's actually like most frameworks have this huge amount of configuration files. We have this error here that says dear env is not allowed. So because this has to be like as automatic and as easy as possible for the end user, it uses dear env. So as soon as you enter the directory, there's a shell, a script that is run to prepare the environment of that specific directory. So, but you have to explicitly allow that to make sure that you're not going to run anything that you don't want to, or some malicious stuff. So, direm allow. And now that I allowed it, is preparing the actual, in this case, for you, it might take a bit more, maybe like 1 minute, because the first time you already waited like 10 minutes for everything to be downloaded and compiled for the first time. But as you can see, for me, it's instant because it's already on my store. So now I don't only have the binaries, but I also have the variables in my path and other binaries that I want to have. So I have everything ready to go to like actually work with the project. So if we take a look at the structure, I think I have. Okay, first the tooling and then the directory structure. Let's see, let's move this here. So I'm going to do it the other way around because I think this is more. First, we're going to take a look at the tooling and then at the directory structure. So There are a couple of directories that you don't care about, like this dev-env and dir-env. You don't really care about this directory. This application directory is the one that is shared by all the front ends and backends that you use. This web folder that has the controllers and the views and the types and the routes. This is our actual front end. This is our, no, actually the controller is part of the backend. This is our application, sorry. This is our application. Has the controller that it works in the backend to render the HTML, has the views that after rendered it's going to be sent to the front end. We have the routing, we have the types, and how to control our URLs. So we're going to go over everything, but this is our app. We have a single one right now, but there's no reason as to why we cannot have another one. For example, for the admin, the administrator have to have some extra powers with extra views and extra everything. So we can create another folder that we can call admin or whatever. And we can share everything else. We can share the static, which is just in this, for now, it's just CSS, the app favicon, and just an SVG, like static files. We can share the static files. We can share the config. We can share a bunch of like helper functions for controllers and views, and scripts that are code that runs on our backend that can be either like cron jobs, like every hour do this, every hour clean the database or something like that, or it could be scripts that run in a specific with a specific triggers, like whenever a new image that it's uploaded, run this couple of binary, run this script or whatever, like make sure that it has the correct size, make sure that it doesn't have hidden content, and I don't know, pre-process it and ask ChatGPT what's that to add as a description, something like that. It doesn't matter. It's arbitrary code that you can write as a script that runs in your backend. So in the application, we have these fixtures that is in this, for now it's empty, but this is going to have all the SQL expressions that we need to create and update our databases. We have our schema as well. That is going to be, the fixture has like dummy data to run stuff that we can share between developers, and the schema has the actual like definition of the SQL tables. And the scripts, I think we also have like nothing. We just import modules there. And here we have the helper controllers, that this function says that these functions are going to be available in all our controllers. Remember what we said, that we're using this model view controller system. So the controllers are the ones that actually do stuff. So, and here we have all the, here we can add stuff that is going to be available in our reviews. Let's see. Oh, this is okay. So this is, if you have this error, don't worry. You just have to like restart, and because the generated types are generated automatically, and sometimes the both in NeoVim and VS Code and whatever don't really get like, it's not the language server doesn't detect that the files change, so sometimes you need to restart. So we have the scripts, we have the helper. So this is the this is not like what you actually serve. It's like helper functions and things that you want to share between the backend and the frontend. We have the config that is in Nix. We're not going to go over much about this, but yes, we're going to skip this, and if we have enough time, we're going to go over it. This is the same as Haskell. This is like the binaries. We don't touch this. We don't care about this. And let's go to the fun part. So here we have the types that represent our application. In this case, we have a single web application type and a static controller that has this welcome action. All these actions do stuff like changing a web and changing to a specific place, a specific URL, creating something in the database, etc. Let's if here we have the routes. Let's see. So if we can, you can see here in types. In types we have the static controller, and we define the type static controller, and then if we want to have an URL for that static controller, we can add an instance of autoroute. This is super big. Okay, let me know if for some reason you cannot see, it's too small. Let me know. So we have to, if we want to have URLs for this action, we have to make it an instance of autoroute. And the front controller, we already saw that, I think. No. So here it's the entry point. Here we define the entry point of our application. So we have the web application type, and we make it an instance of front controller, and we provide the controllers. And one of the controllers is the start page. The start page that has this welcome action. So whenever our application starts, it uses this welcome action controller. And if we want to see what's going to be rendered, here's the, if we want to see what's going to be rendered when we run the welcome option, we can go here to the we have a prelude. Of course, controller has a prelude, view has a prelude, because we want to have custom functions and types. We don't want to use the usual prelude. So if we go to static, here we have the controller that renders the static controller here. To make a type, an actual controller, we make it an instance of the controller type class. And let's see if we enter GHCI and import web. Okay. I know what's going on. Just in case, let's restart everything. Just to make sure. And we can also, right now, we can use code, so it's friendlier. Okay, let's go over this. We were in our controller, And if we run make GXCI, we cannot use the regular GXCI because it needs to import and run a bunch of stuff. If we want to know what you can do, here's the make file. And it's not here, but maybe somewhere here, maybe we're going to encounter it later. It's the definition of make, of all the make that we can do. So if we make GSCI, why it's not working? Let's see. It should work right out of the box. Let's try to run it. Let's try to run the actual application, okay? So this is the backend. This is the tooling that we have for free for using this. The schema is empty, the database as well, empty. We have also code generation, which is really convenient. We can generate controllers, actions, views, mail. We can send mail as well. We can generate mail, background jobs, scripts, migration applications, etc. But I want the actual application. Let's click here. Okay, so here's the app. Has nothing interesting so far. And if we inspect, you can see that it's just plain HTML, nothing interesting as well. So the interesting part is on the backend. So let's see. We have this open. Let's see if maybe we can start working on it. So we can use the start. Sorry, we can, if we go here, we have the start, which is like nothing interesting as well. So the start, if you as soon as we run the start script, not only it starts our user interface and our backend and everything, but also it automatically starts the SQL database. So it's already running in the backend. We don't need to start separately. And here we have in this GUI-based low-code, no-code tool, we can manage our database. We can design schemas. We're going to do that. We're going to spade and modify databases. We can perform migrations. We can generate code. We already saw that, access app, and the documentation. And we can potentially deploy as well to an actual server to be used by our users. And on top of that, we have a bunch of built-in scripts to do common operations. It's like the one we saw make GXCI. Yes, let's go over this super quickly. Application is the domain logic. As we saw, it's shared between the front and the backend. Then we have the configuration. You can configure the actual app. You can configure the framework and the dependencies. Then we have static files, same as always. The web application controllers. This is your front-end application, at least your initial one, but doesn't need to be the only one. Here in GSCI, the config file for your interpreter. Here in the default and flake nix expressions this is a bit different than the usual Haskell. If we take a look at the if we take a look at our cabal file, usually in the cabal file you see the whole configuration of all the binaries, etc. In this case, we don't, because we see this. We have this app executable. The main is main, right? The main is right here. It has just the front controller and the workers. But where's it? The build depends off IHP, base, while, and text. And then we have a bunch of extensions, and that's it. like we don't have the actual configuration of each binary and each thing that we want to, each dependency we want to install, etc. So this is because this is right here somewhere. This is auto-generated, and you don't need to touch the Cabal file, because if you want to install, here we have the extensions that we need to use. But if we want to install something, we have to use these flake duct nicks that we actually want to use. If we use flake duct nicks, here we have Haskell packages, and we can install whatever we want here. So pretty much almost every Haskell package is available here, and if it's not available, you can make it available with a Nix expression. And so at some point we're going to use it to create to add markdown to our blog. So I'm better to keep going because I'm running a bit late. Okay, so let's start. Let's see what time is it right now. It's past.
Yeah.
Should we keep going or
like
yeah, super short?
Sure. Yeah, I think
break.
Yeah.
Okay, after, just as a teaser, we're going to actually start adding stuff. I'm going to try to do it a bit faster because there's a lot to cover. But yes, if anyone has questions, please interrupt me, because like the whole idea is that you should be able to use this framework from now on. So please don't be shy. And yeah, after the break, we're going to start actually writing code.
Okay.
See you in 10 minutes. Took a while. It took a while to get here, so I will try to speed things up and maybe do more than tell. And so we want to build a blogging website, so we need posts. To do that, we're going to create a post table using the SQL schema, this tool. So we can just, let's say, zoom in a bit, create a new table, posts. And there you go. We have the table created, and it's not yet live. We have to migrate the database to have it live. But we can start creating columns. So we have the ID column with a type UUID that is generated by default, and it's the primary key of the posts table. So we can add a title of type text that is not nullable, it's not unique, it's not the primary key. So we can just create this, and we can create the body of the text. And there you go. We have like our schema designed. And now I'm going to zoom out a bit so it looks better. And now we have this available in our app. So we're going to migrate the database. This is the code that is going to be run to migrate the database. You could run this by hand, but like the whole point of having this is that you can avoid doing this repetitive stuff. So there you go. I run the migration, and now if we go to our database, we have the posts table ready to go. So we could check if you run make PSQL, you can connect to the database and you can run queries as you normally would. We're going to skip that. We can also, because it's like obvious, but we can also see the changes of the database using entry into the schema SQL that I told you earlier. In the schema, application schema, we have the same code that we just generated, so it's saved there. And now What about the types? Because we have the record in our database, but we also need it in our actual application in Haskell. So these types are automatically generated, and in this case we have the type post that has this ID of type ID post. This ID is represents this UUID in the table. We have the title of type text and the body of type text. And an example of how this might look is we have this post ID, and this is our auto-generated ID. We have the title and the body. So, and here it says that the type ID post is just a new type wrapper around the UUID. So it doesn't add any functionality of top of being a UUID, but it adds type safety. So in this way, you cannot use an ID of another table, like a comments or users table, in the post table. So you have type safety. The IDs of one table cannot be used in another table. That's pretty cool as well. And if you want to dig deeper into the generated code, we can ask here in the schema, show generated Haskell code, and you get all the Haskell code that has been generated, which is just what I told you earlier when we explored the database, that we need to like create all this, create row and read row, etc. Well, in this case, we already have, let's see if we can look it from here, or we can actually go to the file that is inside this build generated types. So the build type is hidden from here. We could show it. We're not. Let's go build generated types, and we go to post, and there you go. Everything in this file is automatically generated. This, for example, this from row is something we need to interact with the SQL database. We saw that earlier, but we don't have to do it. This is just done automatically for us. It's amazing. We have instance of can create as well, so you can create, can add, can create post, can update post. This is all to interact with the database. We have the record type, post, the query builder. So all in a way to set fields, a way to update fields. So all this is automatically generated for us. We don't actually need to like, we don't need to check this into GitHub as well, because that's like automatically generated. So now that we have this, we already went through this. We have the types, so we have a way to interact from the backend with the SQL database, but we still need a way to interact with the user. And that's when we have to generate or a controller with its views. So we have the model. The model is the record type that represents the post. That's the model. That's it. But we need to, if we will have to do this manually, we need to like write down a bunch of code to generate the controller and the views. Luckily, we can just use the generator. The generator is pretty basic, so it creates, let's do it first and then go over it. So we can either go to code generation, create a controller, and write posts, and we can click on preview and it will generate. Or we can just go to the schema, right click on posts, and click in here in generate controller. So in both cases, we get into this UI that tells us, okay, so I'm going to add a web controller with posts. I'm going to append this instance auto root with the type post controller to the roots. So now you have roots. So you have the post controller, you have roots, you have the type with all the possible actions that you can take regarding the posts. So you can create new, you can show them, you can create, you can edit, you can update, you can delete, etc. The front controller, to actually show them in a specific URL. This web routes generates the URL. The front controller relates the URL to the front end. Then this is the same as the previous one. This is in the same movement. And then we have the actual views. As you can see here, it says web, view, post. And we have the index that shows a list of posts. We have the web controller, the controller for the post that imports the view. We have the view, like the actual HSX that generates the HTML to create a new post, and to show the post, to edit the post. So all that is automatically generated. Here KMs ask if we need custom queries. Will I need to edit the generated models? Do it at the schema level? Okay, yes. So usually the easiest way is just to generate them and modify them, and we actually do this. I'm going to try to accelerate the process so we get to actually do it. But yes, once it's generated, it's your code. You can do whatever you want with it. It's not like the types that relate with the database, that just when you modify the database, the types get generated automatically. When you generate the views and the views and the controller, it's generated once, and then you can modify that however you want. And we're actually going to do this in the lesson. So we saw this. We can actually, if we we're going to just add init commit. There you go. So now we have like everything previous to the generation, and now we can click here and generate, and that's it. Now if we go to our file, we can see all the, it's updated. We can see that the web controller, the web has a new post controller and has a new folder of called posts that has the edit, index, new, and show. Let's see, we have another questions. Oh, okay, okay, perfect. So let's explore this a bit, just the posts. So we have the instance. I'm going to zoom in and close this as well. So we have the controller instance for the post controller. Whenever we want to make an instance of the controller, we have to provide the action that is going to be run whenever we pass each possible constructor. So the action for the post action is going to query everything of type post, because we have a single table of type post, and we can only have a single table. We cannot have two tables with the same name. So we're going to query all the posts, and this is the query. Let's see, should I? Okay, no, you know what? I don't want to run out of time before we get to do the cool stuff, but we have to see this because it's super important, the query. So if we go to docs, let's close all this. So this is the app running, all good. But if we go to docs and we go to the very end, we have this thing called API docs. we have our own package with only the packages that IHP uses. So we can, of course, like open here in the terminal and say make gxci and load compiling, and then I can import web controller posts, and now I can ask about we want to know more about the controller instance. So controller not in scope. Okay, let's load import controller. It should. Okay, no. So my bad. It's in controller preludes. There you go. So the controller instance, yeah, it's so we could like explore this in this way, same as how Lars did the whole time, but we're going to save some time and just check it here. So if we quick jump into controller, let's see, controller. Let's see, controller contexts. I want the instance of controller. Where is it? Here.
Yeah.
Okay, let's see. See, as path controller. Okay. So somewhere there is the instance. I just don't want to waste too much time in this. So the point is the controller is a type class, as you can see here, that takes a single a type and returns a constraint. So we have two actions, two methods, the before action and the action. The before action is something that runs before I render the HTML. So for example, you could like query something that is not in your database or that is in your database, or you can like run a service or use a different API always before running. And the action is in the moment that is everything is actually rendered and sent to the front end. And the minimal definition is the action. So in this case, we only need to provide actions, so we only provide actions. For the post action, we provide we query all posts and use this render to render the index view. These 2 points just means that everything that is the part of the index view type is requested here. So if we go to the definition here, we have this data type called index view with an index view constructor that takes a post value of type list of posts. So it has this warning because it has a single constructor, and there you go. And so the whole point is that if I have to pass a post, so I can go to the previous place and I go here and I can just write post. That's it. It works. But because I might change whatever I need to pass to the index view, depending on whatever information I want, it's easier to just write these double dots and change only this definition. So if I change the definition, nothing breaks because it's and the Haskell understands, the compiler understands that I need to pass everything that I pass here. So that's another thing that you might see frequently. This is another language extension. So let's go back. So we have the post action, and remember, because we have an instance of post controller, we have URLs for every single action. So if I want to see how this post action renders, the only thing I need to do is see what says up until the action word. So in this case is posts, and in this case is new post. And I can write down that into my application. So I can just write post.
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 Yes. Yeah.
And there you go. I have my post.
Yeah. We have a question.
Oh, sure. The double dots are IHP specific? No, good question. So no, the double dots are just an extension for record types that it's used pretty frequently outside this framework. So one of the things I wanted to do, but sadly won't have enough time, is to go through the most important extensions here. But one of the extensions, if I record wildcards, we have disambiguate record fields to duplicate. And in this case, the double dot is the record wildcard. So you provide this double dot. There is like a wildcard that means I'm going to pass everything the record needs. This not could be like a partially applied record. It's just to be a whole record. And so you can just avoid to do that. I mean, I want to go through this, but maybe it's a future lesson, hopefully. Another thing that we're going to use quite a lot is called implicit parameters. That's we'll see if we get there. But it helps understand. So okay, let's go. So we query the database and we render. In this case, when we create a new post action, we have nothing to query because there's nothing there yet. So we create a new record. Remember that everything we're doing here, you can search here. So if you can quick jump to query, and here it says, okay, represents a select everything from something query. So it's the starting point to build a query, which is like use this query builder, and on top of that, we can add more stuff. Like here, for example, we can, to query all the active users, we can start the query with the query of type user. We want everything from the user table. And I want to filter when the user has a field active, this hash and active. Hash and name represents this the columns. So if I write hash title, I'm accessing the title of the record, and so on. These are just like simplifications to like not to avoid too much work. And after that, we do the fetch. We have the pipe operator that as well, we also don't, I think Lars didn't say anything about the pipe operator. I particularly not crazy about it, but it's widely used in this framework. As you can see, if we scroll a bit, we have the pipe operator. It's super easy. So if we get some information about the operator, we see that it's a polymorphic type with no constraints. So like we already learned, that means that the actual definition must be super specific, because there's pretty much only one way of doing this stuff. So we have a value of T1 that could be A, for example, and a function that goes from T1 to T2 and it returns T2. So the obvious thing is that it takes this value and applies this function to this value to get the second value. And that's actually what the pipe operator does. And if it sounds familiar, it's because this is the function application operator, but with the inputs flipped. We have first the function and then the value that we want to apply the function to. And with the pipe, we have the value and then the function we want to apply to the value. But at the end of the day, they do the same. And maybe if we can actually like search for it and see where is it, see the definition, we can see that it's like the most simple definition ever. We have the value and the function, and we apply the function to the value. So super easy, but is, oh, I closed it, sorry. So, but it's all over the place. So just, I wanted to tell you, just in case you don't get confused. So I can change anything that is built like this with this function application. I can just flip the values and remove this, and it's going to be fine. So we have the edit post to edit the post, update post action. This we are going to, in this case, we fetch the post ID if we open the types generated, no, the other types of the web, and we go below, we see that the post controller type has all these actions, and some of the actions require a post ID. For example, the show post action, we need to know which post to show, so we need to pass the post ID. The edit, update, and delete as well. So that's where it comes from. I'm going to close this. So in the case of edits, updates, and delete, we need to pass the post. Then we have to fetch. We have to fetch the post as same as before. We can just quick jump to fetch. Fetch. Let's see if we can. There you go. So fetch is a method on the fetchable type class. So this doesn't say anything here, but the fetch is the actual action that we, as you can see at the very end, we have an IO here. So that means that the fetch is the final thing that we do once we stop constructing this. So when we, for example, create the query, we're just creating the query, but we are not interacting with the external world. We're just doing stuff in our own program. And then when we actually fetch it, that's when an IO action is performed to go get the value and bring it back. And you can only do IO actions. I mean, you can do IO actions pretty much everywhere except in the views. The views, they are the ones that actually render the HTML. These are pure functions. So there's no way you can actually perform an IO in this. So that's a good thing, because that means that all my logic remains in the controller. It's forced to be remained in the controller. And I get to just here just to represent the view without any like real logic. Of course, I can like write functions. For example, we have this render post function. I'm going to move out it. We have this render post function, and this is the index view. So this is actually what we see right here. This view. And as you can see, we have a link here. This is called breadcrumbs. We have the index. We can create a new post. And actually, we click here. You can see the breadcrumbs expands. Now we can go back to post if we click here, but we're actually in the new post action. So now the controller in charge is the new post controller. You can see here in the URL. And First body. That's so. And now when we click here in create post, what is going to run is create post action here. So it's going to create a new post. It's going to run this build post function that we're going to take a look at. And then it's going to validate, check if it's valid. So it fills the criteria that we're going to see right now as well. And if it's not, it's going to render again the same new view and not do anything else. But if it's right, it's going to create the record. It's going to actually modify the database, set a success message like the one, if I'm going to click and create, we have this post created. This is the success message. And at the end, is going to redirect to post list, which is why we redirected to the post list. So all the actions that is taken in the create post, action are reflected in the UI. So now this build post as well, this is as well interesting, but maybe hopefully we won't have the time to like go over everything. But in the build post, initially, we only have one requirement. We need to have a title and a body and use those to fill the record. That's pretty much it. That's the whole requirement so far. But in the future, we can actually add validations to it. We can add that the text has to be in some way or another, it has to be valid markdown, etc. So let's keep going. One thing that I want to quickly say, that maybe if we have the time at the end of another day, we can explain further along. These strings, title and body, are not value level strings. These are type level strings. These strings cannot be wrong because the compiler won't allow us to use, for example, title as a as a valid value. We already have an error here. If we can go to problems, could not deduce here. Could not deduce the blah blah blah. So it's like at the end of the day, these things that this means I couldn't find something in the type post that translates to this string. Basically, that's the whole thing. So as soon as I fix the string, everything works again. This is really good. So that means that there's no way for you to mess this up. So let's see. So now we have our post. We actually created one post. We can, all this is created automatically, but we can and will modify it. We can show the post. And as you can see, we have the string representation of the data type of the model. We have the ID, we have the title, the body, and we have meta. This is contains the metadata of the metadata of the post, and that's it. Let's see if we can. We have time to explore the metadata. Let's see what comes after this. So we already have everything generated. Here we have a table explaining the relationship between the action, the request is the description. Post action is the request, the get request of post. So that's why when I write /post in the URL, I get a get request that gets a list of all the posts, and this is run by this post action. As you can see here, I have no parameters, but then in show post action, I need in the type, we already saw this, that the type requests a post ID. And this post ID has to be a parameter of the URL. And if you see right here on the top, maybe it's too small, but it's show post post ID equals a bunch of numbers and letters that match the numbers and letters here. So this is how the front end communicates with the backend using these URL parameters. So as if we need more information, we will have more URL parameters. Initially, that's the way, but we can change that if we want to have these SEO friendly URLs and stuff like that. Okay, so let's keep going. We can edit the posts, updates. If you have any questions, please let me know. Okay, so exploring controllers implementation, we already saw that. The actual code that is run when an action is executed is defined in application controller in the name of the controller. So exactly. So if we have here in web, we have the controllers, and now we have only posts, but our application is web. In this case, it's just a wildcard because it depends on the application we want to use. As I told you before, we can have multiple applications. So all the code that actually runs is inside this post controller. This is the one we have open here. The controllers always import a special web controller prelude module with a bunch of helper functions and stuff. It also imports the views because it has to know what to render. If we go here, the edit post action, we have the action that moves us into the edit post. For example, here we're in show post, but if I go to edit with the same post ID, I get into the edit post URL. And for the edit post action to be able to redirect me to that specific view, we have to provide the render edit view. So that's why all the views are imported into the controller. To create a controller, we need to make a type and instance of controller, and we have to define the action. We already saw that. Let's explore the type class. Okay, we already explored the type class. Awesome. Okay, so now the view, we already explored the view quite a bit. So, sorry, the actual code that is rendered is in the application view controller view. So it's a view here, application, view, the controller. This post is the same. The name of the folder is the same as the name of the controller. And then all the views available in our post for our posts. So that always follows the same structure because it's generated automatically. So we have the index view that we already saw. To create a view, we need to make the previous type a type of the view type class. So if we go to the index view that we saw earlier, let's close this. We have the type, and it's just a type. Like right now, it's just a Haskell type. But then we make it an instance of the view type class. And to make it an instance of the view type class, we have to provide at least the HTML. And actually, if we have the option to provide the JSON view. Here. So the view type class, to have a minimal complete definition, we have to define the HTML that the server needs to respond to the client. But we can also write the before render, and we can also provide the JSON in case that we want to have like an API instead of an actual HTML. We can just return JSON, and we have to. The only thing we need to do is to, instead of define the HTML here, we define the JSON, and that's it. So now that we define the HTML methods for the index view, all of a sudden, this index view is an actual view that we can return. And that's why we are able to render it when we are here in the controller. We are able to render it because this is an instance of view. So as we saw earlier, this is HSX. And here we have this breadcrumb. The breadcrumb is an interpolated value. And if we go to the definition that is right below the one we have right here, if we go, there you go, we have the breadcrumb that in this case just has this post action, and it, in this case is just this thingy right here. You can delete it if you want, but it's just a way to easily go back and forward for the user. So as you can see, we can create functions inside the function that we use to render, and we can use them inside HSX. Then we create H1 that is called index, that has a path to the new post action. No, the H1. Okay. This is a button. There is a plus new. This one has plus new. Is the href takes the path to. This also comes with the framework. It's a path to the new post action. So whenever you click this href, this anchor, this button, it redirects us to whatever the URL is for the new post action. This way, you have to as well, you don't need to hard code anything. You can just modify the new post action however you want, and everything else will be like changed as well. And the classes are the ones provided by Bootstrap, so not really interesting. And then we have this table with posts, and let's go down. This is maybe interesting, but we have a list of posts, and we want to render all of them. So for that, we create the render post function that we see right below, the render post. And this render post function takes a post and returns an HTML. And in this case, the only thing we use with the post is to just take the hrefs. So we have the post, we have the post ID to show, we have an edit. So this is maybe lame, so we can change this. For example, the post, we know that it has a title, so why not just render the title? And we don't need the show anymore. No, we do need the show, but I know that I wanted to do this. Another thing that we could do is that having a separate show button might be overwhelming, might be too much for like to load it for a UI. So we can just take this and put it right here, and right, as you can see, I'm having an error. It's a type error, so I know that something is wrong. And now that we have this, we have the name of the post that is clickable, and it goes to the show post action with this specific post ID. I don't need the show anymore. And because I just have 3 tables rows, I just need to remove, I just need 3 tables header. So now, let's see. This is how it is now. And now if I save, this is how it is now. Much nicer. And if I click this, I go to show the post, which is not really fancy right now, but we can check that. Let's see. We can explore the type class, no need. Explore it. Oh, I'm going. Let's see. View, slideshow. Okay, so displaying a post as well as we have if we go to the show, as you can see, we have view, web view posts, and the show file. So this is what is rendered as well. This is a new type. This is what is rendered where there's, when I click in the post, this, which is horrible. So I can change this a bit. I can, let's see, in the H1, I can just remove this and use post title, and in post, I can just body, and let's see what's wrong here. Here.
Post, yeah.
Okay, there you go. So now that I save this, it looks nicer, way nicer. Thank you, Karina. And let's see, let's keep going. Let's go super fast. If anyone has any questions, let me know, please. Yes, we have a question. Is pagination error filtering provided with the models? Yes. So we have, if we go to the controller, good question, great question, because it's like actually needed most of the time. So if we go to the controllers here in the query, we also have the way of limit. Let's see, I think if we just search for limit, yeah, in the query builder, we have a way, let you go, and we limits and an offset. So I can just, in this first case, I can query and limit the query to just the first 10 posts and then fetch. So I select everything from post with limit 10. And then I can, actually, you're just write this from the get-go, but you can limit and offset. So you can you have to keep track only of the offsets, then which offset you are right now. And that's it. You can like paginate that way. The first time is going to be the first 10, the offset 0. And then when you click on the next page, you're going to send a parameter like the ones we have here, saying page equals 2. So, and you multiply and you use page times 10 here in the offset. And there you go, you have pagination. And there you go. So let's, we already did this, amazing. So we made the title of the post clickable. Amazing. Adding timestamps. Okay, now we're going to change the queries a bit. So blogging usually has this post order from recent to the latest to recent, and you want to know if the post was written like a decade ago or not so much ago. So we're going to add timestamps. And the first thing we need is like a way to track the time. So we're going to add the created at column to the post table. So let's just to make sure that I don't have anything mid editing. We're going to go to this IDE post, and then I just use a new one, and I can say add row. No, what's this? Post, sorry, data schema. The data is the actual data, but the schema is where you define. We can just create here and create a new one, but also the framework provides this created at, updated at, user ID. So it's like pre-made, usually used columns. So We click and create a column. So we added the created at column, this of type timestamp with time zone, and the default value is now. You can see created, the default value is now. So, but it's only on our schema. We need it in our actual database. So we're going to migrate. We can see here what is going to be done. As always, if you should do like a git commit before. And actually, if we something, there you go. And run migration, there you go, it's already done. So now the only change is that this table was added, so not super interesting right now. But now we are able to order our posts. Database looks outdated, fresh. There you go, a small refresh. So if we go to the web controller posts, we can alter the order of the posts. Let's see if we go, let me close this. I think it's okay if I close this and just use this controller. So we have the web controller posts, and here we first create the query, but it's just a select everything query. And then we fetch it. The fetch, as I said previously, is the act of getting everything. So we want to modify before we fetch and after we create the query. So we can create this. And here we are going to add another action and another action. And as you can see here, we have this order by descent. And not only that, we have also, if we go here and say order by, we have order by, and we need to actually provide the which order we want. We have the order by ascent and order by descent. Or order by descent, fetch the 10 newest projects, order them by creation time. So we in this example, we first order the first, the latest, the newest 10 projects of some application. We limit the we order everything, then we limit to the first 10, and then we fetch. In our case, we're going to fetch everything, order by descent, and then we have to tell it order by what? By the title, because we could order by alphanumeric, by number, by whatever we want. So we want to provide the order by what. And in the database, we have all these options, and the created add option is the same, but if I created at, check out how the created at in the database uses underscore, and in Haskell uses the camel case. So everything that in the database uses the underscores, in Haskell uses camel case. And that's it. Now we saved. And if we go to the app, we had just one post, but then second post, and the second post, which is the newest, goes first. And if we do as, it will flip, but we want the newest one. Perfect. So that's how we can, that's a new, something more realistic in the day-to-day. Like you already have your table, but you need to something new. So we modify the table. Once it's modified, we have access to all these types that are generated automatically for us. So then we change the query, and if needed, we can change the query in the controller. And if needed, we can also change the show. In this case, now that we have the created add, we can showcase it in the UI. So if we go to the index view here, let's see. No, the index view. No, I want the show post, which is the action. If we click here, is the show post action. That is the one that renders this. So I go into the show post action and it renders the show view. So I'm going to the definition there. And here I can add, for example, the, if I say post, now post has because the new created at
Great.
for create
Today.
there you go. Thank you. Now between GHC and Karina, there's no way I'm going to mess this up. Okay, so we have this created at, and now that I already saved, we can see that the time that when it was created, and we also have this really nice time ago function. We have of course datetime function that takes a time and returns an HTML that displays like a nice date. But this one is particularly nice. This time ago takes the UTC time and displays an HTML that looks like this, like 5 minutes ago or 10 minutes ago or like 3 days ago, whatever. So in this case, I can just take this value and pass it to the time ago function. And if we take a look at there you go, 2 minutes ago. So if you here in the, I made it with like following the same procedure as they do with the pipe operator. But this is just so small and so, I mean, and also like this could be no, I mean, there's no need to do just the pipe operator for something so simple. But yeah, now we have a nicer, but a nicer post, but we can still do more. And this is nice. This is something I wanted to make sure that I arrived to this point, because it remarks the value of nicks by using like taking this extra step of using nicks. So in this case, we want our posts to be written in Markdown because the plain text ones that we have now are super boring. And if we take a look, I mean, you could explore a bit. You could explore a bit about which Haskell libraries you want to use for this. But I'm going to tell you right now, there's a really cool one called mmmark that is a strict Markdown processor. So it does 2 things. If we explore it a bit, 3 things: parsing, scanning, and rendering. So we have this opaque data type, mmmark. And this data type has an internal representation of a complete Markdown document. There's no way for us to explore it, but we can interact with it. We can use functions provided by the library that allows us to interact with it. One of those are the parse function. So the parse function takes a file path in case you want to like read provide error messages and stuff like that, and then the actual text that you want to parse, and it returns either the parse error bundle, like an error with the text and an mmmark error, or the actual correctly parsed mmmark. So now we have valid Markdown hidden inside this mmmark type. So now that we have this, if we go scanning, now we have this. As you can see, super short, the library, like super easy to understand and short. So it's like 5 minutes of reading. But now once we have this M mark, we have to provide the text to get M mark. And now we have M mark, we want actually HTML. And we use this render function that it's able to render HTML to text by stream and file. So we're going to use this mmark library to parse our text, make sure that it's actually a valid markdown, and finally render it when we show the post. So this is really cool because now all we need to do is to go to the thing that I couldn't explain, sadly, was for lack of time. Nix. We go to the flake, and let me zoom out because just to show you that it's not much. It's just zoomed in, but it's not much. But inside here, we have these Haskell packages. And inside here in Haskell packages, I can just write mmark and save. And that is now going to be part of all the packages available for me in any place in my code base. The one thing that, of course, we need to do is to restart the environment so it actually downloads it. So if we go to the console output terminal, I'm super zoomed in. Terminal, I have to close this. And here I'm going to kill this. DRM up. Oh, I have to go. Let's see. Should I go completely outside? Yes, sure. Okay, exit. And maybe with just in case. Let's see. Let's try to import it. Let's try to where I want to import it. Show. Let's go to show post. And if I go to import qualified text mmark, no. Will not find model. Yeah. So I need to, I usually call in NeoBeam, not in this. So I'm not sure if I should have just to, maybe I can oh my God, reload window, that's it. Let's see. If not, yeah, I think that's it. Let's see. No. Okay, so I'm going to kill this and DRM up. Let's see. Right there. Ah, sorry. It's not DRM. It's dev emp. Sorry. Sorry about that, but I think that should be it. Yeah. Yeah, if I use the wrong command, of course, no problem. So let's enter VS Code again. dev env. This should work. It works. Perfect. So yeah, remember to always use the correct command. So it's dev env up, and then that's it. It works out of the gate. And I think I killed the process. Let's see. Yes, I did. No issue. I just run start. That's it. So now that we have a way to process Markdown, let's create a function same as we have here. We have not here, but somewhere else we have this render posts. Well, we can just create the render Markdown. We can create it outside, or we can create it here inside, render Markdown. And this is going to take text, and it's going to return HTML. Render Markdown and text. And now, as we saw before, we have this parse function. And the parse function returns an either. So if it returns if it parsed correctly, it returns the actual parsed, the actual type that we need to render it. If it not, returns an error. So what we're going to do is say, okay, in the case that, in the case that mark parse empty file, because there's no file that we want to pass, parse text off, and now we have, let's see, we have two cases. We have left with an error. We don't really care about the error, because for us it just means something went wrong. So we are going to return no,
Something went wrong.
Markdown. And right, we have, if it's right, we already have the Markdown, so all good. And in that case, initially we thought that we can just return the Markdown, but it's not what we actually need. We have this thing of type nmark, but what we actually want is HTML. So we can use, I mean, we can explore, we could, but we're short on time, so we won't. So you have to believe me. No, you can explore the types and that's it. We can explore the types and say, okay, if I could show this, and then after showing it, I will, this is a bit, after showing it, I will have a text, something of type text, and I can use this function called pre-escaped to HTML. Actually, it's like
This show things. Okay.
See, yeah. But this show,
Yeah.
this, yeah. So as you can see, I just wrote it like regular Haskell, and he's written with it pipes. It's however you prefer. But now we can actually check if it parses, and after it parses, we can actually render it, the Markdown, which I found it's really cool. So we have to now that we have this render Markdown function, we have is here in the post body, instead of just rendering the post body as it is, we can just render Markdown. And now we should be able, what's that? And mark, oh yeah, for sure. So, small detail. I needed to actually render and mark render. No, there you go. So the thing is, this is an embark data type. So when I apply show, I just have the string representation of the data type, not the string representation of the render markdown. For that, I need to use embark render that returns the HTML, escaped HTML, then transform into text and use the pre-escaped to HTML to actually have the final value. So now it looks nice. And if we go here in post, and we can create a third one, third post, and this post uses markdown. There you go. Now we can use markdown to write our posts. Let's see. What's next? Adding validation. Yes, this is important as well. I mean, everything is important. So if we want to add validation, I told you previously that, oh, we have a question.
No, it's only a comment. And say, nice one. Yeah.
Okay, nice. Yeah, yes, indeed. It's exciting. So, I told you previously that we have this build post in the controller. If we go to the controller and posting, we go to the very end, we have this build post that is used a couple of times, like here, that the only function of build post is to take whatever URL parameters are there and fill the record type with the values of those parameters to be able to later record that in the data in the database. So now we want to actually make sure that everything is on point. So what we're going to do is we're going to modify the build post and add a few validations. Let's see. Routine checks. Okay, third point, routine checks. Let's make sure that title is not empty. Yes, and that body has a minimum length of 50 using the validate field function. So if we come here, we first have to fill in the values, and after filling them in, we can validate a field. For example, the first field we can validate is the title field, and we want to make sure that is non-empty. That's the first thing we want to check. After that, we want to make sure that the body has minimum length of 50 characters. There you go. And one thing that is specific to our use case, so like some custom validation, so then you know how to create your own custom validations, is that we can check if the markdown is actually valid markdown. So if we take a look at validate field, blah blah blah, here non-empty returns a value of doesn't return a boolean, it returns a validator result. This validator result, if we do some checking super quickly, validator result can be either success, failure, or failure HTML. We only need to use success or failure, and that's pretty much it. So let's write, we need some function that returns this validator result, so then we can use it, we can pass it to the validate field function. So what we're going to do is to create our is markdown function that takes text and returns a validation validation result. Validator. Validator result. So text, and if you take a look at what we have here, it's pretty much the same we did before, but without the rendering. So we just need to make sure that the case of mmark or mmark parse an empty result for text off, and we don't have mmark, so we have to import qualified and text mmark as
import. You put in import. Yeah.
Import, there you go, thank you. Okay, so now we have mmark available for us, and yes, and we can start working with it. So in the case that is wrong, again, we don't care about it, but is we cannot return just a string, we have to return some failure. So we can serve failure with a string. Remember, this is actually a text, it's a string of type text. It's not a list of characters. So in this case, we can say wrong markdown. And if everything is right, we also ignore the result because we only want to know if it's okay or not. That's it. We return success. And there you go. Now we can validate the field body again, but in this case, to check if it's marked down. And now let's try this out. See if I messed up some weird way. So first of all, everything is empty. Let's try it out. Okay, perfect. The field cannot be empty and it's shorter than 50. So for post, and this is shorter than 50. Great post. Perfect. Now this is longer than 50, but it has wrong markdown. Now we use the single star, so the markdown parser is looking for the star that closes this, so it's not valid markdown, so this shouldn't pass. There you go, wrong markdown. The wrong markdown.
Very wrong.
This has the right markdown. There you go. For both italics. Amazing. Let's keep going. So that's how you can add use already present validation and custom validation. So let's add comments to the posts. Now we can start like all over. So because we already kind of know how it's going on, we can go a bit faster. But so we have to go again to the schema designer and add a new table of comments with fields of ID, author, and body. But we have now the post ID one that is a foreign key constraint that limits the comment to a single post. Each comment has to belong to a post. And yeah, so let's create that. So let's go here and create a new table. Comments. And we have to create First, we have the ID, post ID. Do we have that? No, post ID. As you can see, we could do this by hand, but because we are using we are writing the things with the same name that the framework assumes you write stuff, it can't predict what you want to do. So it's just, in this case, not creating something without telling us, but at least it's like proposing, okay, you just use underscore ID, so I know it is a UUID, and you just write this post that is the single, is the same name as the table with that yes. So I'm guessing your reference is posts. So kind of like that. If we can just write something else and change it, but it's convenient. So we can create the post ID column, and then we can add the author of type text and the actual body of the comment. Amazing. And one little thing that we're going to add here as well is that the post ID, we have this foreign constraint post that if we edit this, no, I want to edit the foreign constraint. There you go. If we edit the foreign constraint, in this case, if I delete the post that I'm referencing to, the comment is still there, doesn't do anything. So that's not really helpful, having a comment without a post. So we can change the onDelete action to cascade. So every time we delete a post, we also delete all the comments that are related to that post. That will keep our database clean. Awesome. So now, same as before, I think. I'm guessing I'm not missing something. Yeah, same as before, migrate database. We have everything, run migration. There you go. That's it. Let's keep going. We have our schema. And after our schema, we need our controller and views. So same as before. We don't need to have this open right now. Same as before. We go to the schema, comments, generate controller, generate. We have our controllers, and now we can start modifying them. After the files are created in the preview, your controller is ready to be used, but we don't want to standalone page. Yeah, we don't want standalone list of comments. We want to integrate the comments as subsets of the posts. So one thing we're going to do is to go to the we have to have a way to reach the new comment action from the post. So we're going to open the show. Now check this out. Now we have the comments, edit, index, new, and show. It's same as the post, but with comments. In this case, for example, the index of comments is worthless for us because we don't need a full list of comments. But we can, I mean, you can delete it, and then the framework is going to tell you, okay, now we have this error, and you can delete that, change that, delete that, change that. That's it. But we're trying to make this fast, so append the comments to the post show. So let's go to the show post, and here we can add a link with an comment with an href of new comment. Maybe it needs there. That's it. New comment action. Let's try it out. So I'm going to add like the fourth post, and have this is add comment. If I click, there you go. I can create a new comment. We have the post ID, the author, and the body. Of course, the post ID is the one that I just clicked in this fourth post, and I'm adding a comment for the fourth post. So we want to automatically populate this. We also want to hide this, that there's no need for the end user to see this. So that's the next steps. Sadly, we are running out of time. I mean, we're already running out of time. But let me see. So the next step was to fill, just so you know, I'm not going to do it because we already ran out of time, but maybe just in 5 minutes I can go over what the next steps. And I also can like actually do it and upload it finished, so you can take a look at the final code. So yeah, we can modify the comments controller and add that you need the post ID. So now we're in the controller, but we need the post ID. So we have to provide the post ID to the new comment action. After doing that, we're going to have a bunch of errors. That's one of the things that I want to show. And then thanks to like Haskell, the compiler being super strict, once we make this change that breaks like 4 different stuff, we have to just, this like a to-do list, then you can go for the first to-do, fix it, second to-do, fix it, third to-do, fix it, and you once you fix all your to-dos, it works again. So after that, we set automatically, we use this set keyword right here to automatically fill in the post ID with the one we passed as parameter. Then improving the UI, as you can see here, you can see the post ID field, but you can still see it. Here, I remove that, I hide the field, the field. We have to modify the UI so it's actually picks up the post ID. Then retrieve the comments of a post. So we want to show a list of comments. When we open the post, we want to show a list of comments with these small changes to the show post action. You can actually have the related comments fetched, and then you can modify the post. So as you can see, I'm hoping you can all see, we have the post here. And here Lars thinks that this is super interesting comment. And we have all these comments that we can then edit, delete, etc., adding just this small HSX. And then we apply the same for each post comment function, render comment. So we apply this render comment function to each comment of the post. Then we can order the comments by dates. We have to just, same as before, create it at timestamp, show the comments, modify this the query, and then we can add a navigation bar. We have this layout thing that renders every time. So this is an HTML that every time for every page is rendered. So anything if you add a navbar here, you will have a navbar everywhere. So this is the navbar. And then, I mean, we can add authorization after the navbar. With the add authorization, we have to again prepare the database schema. In this case, we want to create the users schema that has an ID, an email, a password hash. That this hash is created using a function, super easy to use function that comes with the framework. And failed login attempts. Then we create this table. We prepare the types. And this, I mean, yes, this might take like 2 more hours to go over the rest of the lecture. I think I might prepare too much for for just 4 hours. More. Then we can create a view. In this case, we can just open this gist because it's just HTML. By this point, you already know how all this works, so it's not point of writing by hand. You should copy and paste it. And yeah, then creating a user, adding login out, restricting actions. This is important. Once you have the user, and you can check if it's logged in, logged out, and if it's the same user as the post creator and the comment creator, you can restrict certain actions, certain access, and you can as well create a user profile page and add a profile picture and stuff like that. Okay, so that was ran out really out of time, but that's pretty much what I wanted to cover. I mean, you have mainly the mainly idea of what you have to do. We start with the schema. Every time you want to modify something from the database, you modify the schema, generate the controllers, and work mostly inside this web folder that has what's wrong with this? Oh yes, you have to reload the window. So that's pretty much it. Any questions or any comments? Yes, we have one. Yes, Anderson, super interesting. So, sadly, I couldn't like go. It was too much of a. I think I tried to bite too much content for just 4 hours. But yeah, it's super interesting, and the cool thing is that, I mean, there are several advantages that I didn't talk about, but one that actually made me really excited is that I've been coding front end for 10 years, front end and back end for 10 years, and for at least for back end not so much, but front end you have to patch update every 2 months, at least every 2 months, because like new library that breaks, new whatever the other thing. So the ecosystem moves super fast, and as soon as you don't want to like keep up to date because there's no time, you have too many projects, whatever, as soon as like 6 months, 1 year passes, it's a pain to like try to run everything because it won't run, the server doesn't run, the front end doesn't run, and you have to invest like 3 hours in like putting everything up to date again, just to make like two small tiny changes. So one cool thing about this is that because everything is on Nix reproducible, if you don't touch the project for 2 years and then you run the Nix shell again, everything still works. So you can just virtually, if you need to do a small little thing, you want to tweak something for a client that 2 years later wants a small change, you can just run the shell, do the small change. I mean, if not, it's not crucial to update, no need to update, and just recompile and everything will keep working. So that's another thing that I didn't talk about, but that's another like, cool thing. You don't need to invest so much time in updating something that is maybe not worth it because it's a small project, or it doesn't have much traffic, stuff like that. But yeah, sorry guys that I couldn't go fast enough, but I think the main points were made, and hopefully you have a good idea of if you want to work with this and how, and of course I'm going to like leave all the code. So, and maybe not sure, maybe if we have time, some other lesson is shorter, we can like keep going. We can like finish this. KM, no worries, it was great. I try and move my blog to this framework to learn as yes,
cool. Yeah.
sure. Yeah, indeed. I think that's the one of the best use case for this, because like your personal blog is something that you don't touch very often. Like you might be blogging but not modifying the actual website. So yeah, that's a good use case for something that is running everything on Nix. Yeah, and I personally I really liked it because it's something doesn't require as a deep level of Haskell, not a new way of thinking like functional reactive programming. It's just plain Haskell, super easy to use, and everything is ready for you. So yeah, hopefully you will try it and like it. And if not, at least you know you explore it and you know that you don't like it. Okay, so if we don't have any more questions, I will let you go and have in peace. Amazing. Awesome. Okay, guys. Well, see you next week and have a great weekend. Bye bye, everyone.
Bye. Thanks. Bye.